Hey, Justin. Good to see you. One thing I will say is if you haven't, if you haven't done the assignment due today, please don't watch the stream or recorded stream until you do so. Because basically all we're going to be talking about is like the stuff that was due today. And it's really cool. Right, so let's give it 5 minutes. I'm just gonna boil some water, okay? I'll be right back. That's almost done. Hey, Vicky. Grandmaster to you. Grandmaster Dahlia. Hey, Aiden. How's it going? What songs are you learning now? I bet you have so much time to make music and practice and stuff, Aiden, yeah? If you had the motivation. I see. That seems to be a problem a lot of people are running into. Even like their hobbies or things they really like and they're passionate about, they're finding trouble to find the motivation to do them, which is, I think, really weird in a lot of ways, right? Because at one point you would say like, oh, I have these hobbies or I have these interests, and the one thing that's keeping me from like doing it all the time is just work and all this stuff. And now that we finally like have the time and stuff, a lot of people are finding that they lack a general motivation, and that would include the aforementioned passions and the hobbies, and I think that makes people even more sad. It's like, wow, like I don't even want to do the things that I like, right? So I'm sorry about that, Aiden. That must be tough. But I hope you do practice, and maybe to motivate, maybe all you need for some motivation is some good old-fashioned capitalistic monetary incentives, right? So why don't you aim to blow up your YouTube channel like me, okay, and get over 100 subscribers like me, right, and start getting some ad revenue unlike me, okay? Because I know I haven't seen it, but I know some of the students have already told me that you have a little YouTube channel, Aiden. Okay, so it's 11 o'clock. Let's try to start at 11:02, okay? And that'll be roughly around 7 minutes into the stream. Yeah. So again, if you guys haven't read the chat a little above, today we're going to be going over the exercise or the exploration that was due today based on the YouTube video about polyphonic singing. If you haven't watched that and if you haven't done the assignment, feel free to tune out. You should only watch the stream or the recorded stream, right, at a later time once you have completed the assignment. Because if you don't, then it's just kind of useless. So again, please only watch this video if you have already done the assignment that was due this morning. Hey Lara, how's it going? Who did something cool this weekend? Some students in my other class, they went biking, they went to the park. Yeah, that's cool stuff, you know? Because you know what I did? I just stayed in here, in this little room that you see. I'm just gonna crack my back. Oh, yummy. Okay. So we have 20 seconds left. Okay, so let's begin. Let's say I want to play a note, right? Or I want to sing a note. And just for consistency's sake with like orchestras and just like the classical music world in general, let's say I want to play an A and I want to play it at 440 hertz, right? So as you know from our previous like explorations and stuff, if a 440 is like an A that goes right, then you also know every other frequency of every other A. It would be 220, 110, 55, and then on the other end it would be 880 and 1760, right? Because every time I double my frequency, I'm basically playing the same note, but it's just going up an octave, right? So, if that's 440, is 880, that would be 220, right? Aiden can probably sing a much more robust A220 than I can, because my range is very limited, especially in the lower registers. Okay, so let's get something really straight though, right? So if you want to play a 440 and just 440, right, and only play like 440, what that'll end up sounding like is like the really basic tones that you get out of a tone generator, right? It'll be like the super pure tone, right? And obviously, like my 440 and Aiden's 440 and Mr. Ross's 440 and even Lara's 440 and the 440 from the tone generator all sound super different. That's because when I pluck a guitar string at 440, or if I ask an oboe player to play 440, what ends up really happening is like you're playing 440, right? I would call this 440, but you're also playing 880 and you're also playing 880 and you're also playing 1760, right? Because anytime you play a note, you're playing both that note and all of the harmonics above it. So the second harmonic, the third harmonic, and even the fourth and the fifth harmonic above it, right? But the thing is, when that happens, this is the loudest one. So basically, you're gonna have like these wave functions, but you're basically gonna have let's see, like what you're like this is the largest amplitude one, so right? So when I add all three of these waves on my string, what it really looks like, and it's gonna be like this really big wave, and then like the second harmonic's really small, and then the third harmonic's even smaller, right? So and the fourth harmonic's even smaller than that, right? There's the fourth one. And when I add all four of these up or whatever, it still basically ends up looking like basically like the fundamental frequency, right? So the answer to the very first question is like, why even when I'm playing all of these notes together at the same time, why do I only hear the bass fundamental one in my head? It's because it's the loudest one, and it has the highest amplitude, and the resultant interference pattern, when I add all of these, still basically looks like the original one because the others were so small. And you can kind of represent them as coefficients, right? So if like my net wave, and I'm going to call this psi, right, is equal to some amplitude 1 fundamental plus amplitude 2 second harmonic plus amplitude 3 third harmonic plus amplitude 4 fourth harmonic, dot, 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 dot. A1 is so much bigger than A2, A3, and A4, right? So the net wave that you end up getting is basically closest to the fundamental wave. Now, how these are distributed, right, basically determines the tone of your voice, right? Who's Mr. NLS? Anyways, so now we can finally talk about like what makes tone, right? So pitch, like the note you hear is frequency, volume, that's amplitude. What is tone in terms of physics, right? So tone for physics refers to the different proportions that all your harmonics play with each other, right? Like, so if I, on 100%, just my fundamental one, you get like that really basic sine wave from the tone generator, blah, 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 right? If you have like 90% this, 5% this, 5% this, who knows what you sound like, right? You'll sound a little different than that. And everyone's voice has different proportions of like how, or differing amounts of amplitude for all of the harmonics, right? So basically when the video was saying like, oh, I can sing more than one note at the same time, that's basically a huge like curveball misconception, because anytime you're singing, you're basically singing all these harmonics at the same time, right? And based on the timbric qualities of your own voice, different different harmonics are going to be emphasized at different amounts, right? And that's what makes your voice your voice. So what is really happening when this lady is singing two notes at the same time? Because basically when I sing, I'm singing like 10 notes at the same time, right? I'm singing the fundamental and like 9 harmonics above it all at the same time. Why? Because if I make my voice, if I manipulate my throat, right, by altering the tension in my vocal cords or whatever, and the size of the air cavity in here, I'm basically changing the natural frequency of my throat, right? But the misconception is that there's only one natural frequency. If one frequency is an allowed frequency, then all of the harmonics above it are also natural and allowed frequencies, right? So basically an object with a natural frequency of 440 also has a natural frequency of 880, 760, and everything above it too. So all of those would also work. And that's why like when like you agitate it and it vibrates, it actually vibrates at all of the harmonics above the natural frequency. So that being said, what's happening when I sing like 2 notes? So what is this lady doing? This lady is altering the internal structure of her throat so that only the fundamental and one specific harmonic are allowed to be natural frequencies. She's changing the resonant property of her throat to only resonate at 2 frequencies. So instead of my throat resonating at all of these frequencies, it only resonates for 2. So when I cancel out all the others and only 2 are playing, it's much easier to hear it as like 2 notes than just like this huge like homogeneous thing. And while in theory we can know why that works and stuff, in practice, how the heck do you do that, right? How the heck do I change the shape of my throat so instead of 10 notes at once, it only sings 2 at once, I have no idea. Apparently, if you look at the rest of her channel, she has like a set of like video lessons to like how to do this and stuff. I've tried. I'm nowhere close to like being able to do that. I don't think I'll ever be able to do that. It's super weird, but that's something that I wanted to just show you because I think it's a really cool combination and accumulation of a lot of different things in waves, right? So the polyphonic singing is an example where we're combining all these different concepts that we learned, right? We're combining resonance, harmonics from standing waves, and superposition and interference, right? So we're basically learning that every note has a series of harmonics above it that we saw here. They're called standing waves and modes, right? And we also learned about resonance and that certain objects all have natural frequencies and they're only allowed to vibrate at those natural frequencies when they're agitated. But in reality, like things like our throat and like a wine glass or whatever, if they're vibrating at this natural frequency, they'll also vibrate at all of these others, but to a much lesser degree. And how strong those overtones or those harmonics are determine the tone of what you're hearing, okay? So basically, this is where interference comes in because any sound you hear is basically an interference of the fundamental note you're hearing and all the harmonics above it. And the way polyphonic singing works, like with the video I linked to, is that this lady has, and like others like her, like the 5 other singers in the world that can do this, have found a way to be able to shape their throat, to change the resonant quality of their throat so that only 2 of the harmonics are actually being played. And in a way, it amplifies the top one so you can really hear it, okay? The other cool thing that you should have noticed is that when she cancels out all the other harmonics and only plays like basically the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 8th, she like goes up the scale, basically the harmonic scale, and she goes ba 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 ba. She's still only singing like the same bass note, right? So when she's going up this scale, she's not really like like doing that the same thing like the way we do it. She's actually singing like she's singing one note at the same time and then the whole time and changing which of the harmonics above the are getting emphasized and which are getting canceled out. And if you hear her go up that harmonic series, it sounds exactly like the way you should have heard when you played it in the tone generator, right? There's a really specific way harmonic series sounds, right? So let me play it for you. Okay, so here I have 440, right? And I'll play 880, and then 1760. Oh, whoops, that's not what I was supposed to do. Okay. So let me play a standard harmonic series. I'll play 100 hertz first. And then I'll play 200, okay? Right, so that's a basic harmonic series where I just went from 100, 200, 300, 400, 500, 600, 700. And this is what you should have done yesterday. And I can do the same for a different series. I can start at 110, okay? And then I'll go to 220, 330, right? Or I could start at 150. That's a little different, okay? Right? And I can go to 300, 450. Oh, shoot. Sorry, I'll start it again. I messed up there. right? So that's your basic harmonic series. I'm sorry if that kind of hurt your ears. So it goes up an octave, and then a fifth, and then to the original note. Uh, and that's the exact overtone series that she ends up singing, right? So yeah, I just think that's super cool, and I highly encourage you guys to like look it up a bit more if you're curious and stuff. And I think that's it. You're gonna have a project. It's like your first real assessment for this remote learning period, and it's gonna be due Monday. And it's gonna be all about musical instruments. And after the lesson tomorrow, I'll give it to you, right? So get pumped about that. And then I think we should be able to move on to a new topic on Wednesday. It'll be light waves. So get pumped about that, okay? Yeah. So no assignment today. Just chill and have a great day.